Welcome to the Georgia Highlands College Math 97 and Math 99 video tutorials. In this video segment, we will be answering the question, how do you factor a trinomial completely if there is a GCF? So if there's a GCF in your trinomial, then it's not considered completely factored. So the very first step you want to do is factor the GCF out first. Then you move into your next method of factoring the remaining trinomial. You set up factors, you ask yourself the question, what factors of C add to make B, fill in those factors, and then finally check with multiplication. Let's take a look at an example. So we'll start with this example, 2x cubed plus 6x squared minus 56. And you can see that each of these terms in this trinomial have at least one factor of x, and they all have at least a factor of 2 sitting in each of those terms. So we will factor this trinomial first by GCF and then move on to our other method for factoring the remaining trinomial. So the GCF here is 2x. And when we divide each of these terms by the GCF, we're left with, well, 2x cubed divided by 2x leaves us with x squared. Positive 6x squared divided by 2x yields positive 3x. And negative 56x divided by 2x is just negative 28. Now we have a trinomial sitting inside our parentheses that can be further factored. So we go back to our old factoring method of factoring x squared plus bx plus c, where the leading coefficient is 1, because now we have an understood leading coefficient of positive 1. So we can use this method. So we go ahead and set up our parentheses, giving space for our sign and our last term. And we ask ourselves the question with our factoring TP, what are the factors of negative 28 that add to make 3, which is B in this case? So negative 28 can be gotten by multiplying positive 7 and negative 4. And the reason I chose positive 7 and negative 4 is because when I add them, they have to equal positive 3. So inside the factor parentheses that I set up, I have positive 7 and negative 4. So that's just that trinomial inside the parentheses factored. Now I want to write the completely factored form of our original trinomial. So we have to bring this factor of 2x down, and it becomes part of our final factored form. Because remember, whenever we factor, we're simply answering the question, what did I have to multiply together to make that expression? We also have a factor of x plus 7 and have a factor of x minus 4. So there's our factored form, and we can check this by multiplying it together. 2x times x plus 7 times x minus 4. Now some students get confused here about how to multiply all this together. They want to distribute that 2x to the x, the 7, the other x, and the negative 4. But that's not correct. And we can look really quickly at an example of just multiplication. So if I have 2 times 3 times 4, and I ask you to multiply those together, you would first multiply the 2 and the 3 together to make 6, and multiply that result with the 4 to make 24. So you follow the same guidelines when multiplying these linear factors. So the first thing I'm going to do is multiply this 2x by my x plus 7. I'm going to get that result, which is 2x squared plus 14x, and multiply that by my x minus 4. So I come here to do my distribution. Each term in the first binomial with each term in the second binomial. And that gives me 2x cubed. 2x squared times negative 4 is negative 8x squared. 14x times x is positive 14x. And 14x times negative 4 is negative 56x. Combining my like terms, oops, I forgot my square on my 14x. That should be 14x squared. Now we have like terms to combine. And we have 2x cubed plus 6x squared minus 56x. Sure enough, we have matched our original polynomial, which means the factored form answering the question, what did I have to multiply together to make that expression, is 2x times x plus 7 times x minus 4. I hope that this has answered your questions about how to factor a trinomial completely if it has a GCF in it to begin with. If you have any other questions about this method or about greatest common factor, please make sure to contact your Highlands instructor.